There are two important things you need to consider when you're talking about functions and their inverses. Not all functions have an inverse. So the first thing you have to do when you have a function to think about is the horizontal line test. And so I have my handy little horizontal line here, and you have to take your horizontal line or your pencil. A pencil is a really good thing to use. Once you have the graph of what you think is a function, take your pencil and place it across the graph so that it hits the graph. Can you get your pencil, when it stays horizontal, to hit the graph more than once? If every time you try it only hits it once, then you must say that your function passes the horizontal line test, so it is a function, and that means it will have an inverse. So this particular function, yes, it passes the test, so it has an inverse. Once a function has an inverse, then you can find the inverse of the function. So the horizontal line test is a quick, easy way to test a function to see if it does have an inverse. It has to pass the test. That means no matter where I put the horizontal line, it only hits it once. An example of a function that doesn't pass the test, suppose I had this parabola here, right? And I try my horizontal line test on that. Does my horizontal line test hit it once? Yeah, right there at the top. But what about all these other spots? It hits it more than once. Oh, how about this one? Does that hit it once or twice? Twice. Imagine this line has to go on forever in both directions. So that does not pass the horizontal line test, so it does not have an inverse. And there you go. There's how to use the horizontal line test. Now, another way for determining if functions have inverses, or in particular, if functions are inverses of each other, if they, when you put a function within a function, in other words, if f of g of x, if you simplify that and you get x, and then you put the function inside the other one, so g of f of x, and you also get x, then the two functions are inverses, okay? So there's the algebra way. The algebra way to determine if functions are particularly inverses of each other. Another way to tell if they're inverses of each other is to look at the two graphs together. So here I have a graph of two functions, f of x and g of x, and they're inverses of each other. I've graphed both of them, and then you'll notice this black line here is the line y equals x. If the functions can completely be flipped about the y equal x line, so if I can take my function and then flip it about that line and get the exact same function on the other side, the functions are inverses of each other. This is kind of a hard test to do. You draw one function and then plot the points of the other one, and put in the y equal x line and see if they're mirror images of each other about that line. That one, it's pretty easy to see. I have another one that's a little more difficult. Let's take this one. This one is a little bit harder to figure out. The first equation is x cubed minus 1, and the other one is the inverse, which is the cubed root of x plus 1. Are those inverses of each other? Well, look at the y equal x line, and if you flip them about that line, they're pretty much the same on both sides. So again, there's inverse by pictures. The safest way to do inverses, I think, is to use algebra, and I'm going to be showing you how to do that. Okay, so you're going to be posed with questions like this. Find the inverse, and you're going to be given a function. And there's a few little steps. The first step, when you're given the function f of x equals x cubed minus 1, replace the f of x with y. So y equals x cubed minus 1. Next step, switch the x's and y's. So x equals y cubed minus 1. Next step, solve. So solve for y. solve for y. So first of all, add 1 to both sides. So how about this? X plus 1 equals y to the third. All right, get y by itself. That's easy. Take the cube root. Cube root of x plus 1. And then write it in inverse notation. F negative 1 equals cube root of x plus 1. This special notation stands for inverse. So if I give you f of x and I say find the inverse, I'm going to say find this, f inverse of x. All right? And it's not an exponent. That is not an exponent. It's a notation that stands just for inverse. So there you go. Let's review the steps though. So you get an f of x equation. You replace f of x with y. Replace with y. Next step, switch. Switch the x's and y's. If there's more than one x or y, you switch all of them. So if this was x cubed plus 2x squared plus 6x, I'd replace all of those x's with y's. And then solve for the new y. And you have your f inverse equation, and use the f inverse notation. So I guess there's 4 steps. All right.